right, so let's review for just a minute where we left off yesterday, which was in chapter 1 in the science. So get out your science books and let's just run through and review a little bit of this. So yesterday we left off with extrapolating, right, and estimating.
Are we going to go over that one? Are we going to go over those questions that we?
Yes, that we did yesterday in the class that you finished for homework last night.
Ooh.
That's right, you know now. All right, so I'm gonna just move this puppy over here. Okay.
Okay. I kind of get extrapolating now that you kind of did it.
Uh-huh.
But it's still, it's like foggy and.
Okay, well then, we'll do the rest of these and then it won't be foggy in your brain. All right, so let's review for just a minute and I'm gonna plug through this, but just turn to the first page. Let's review and then we'll go on with extrapolating and estimating. And then we're gonna finish this chapter and we're gonna do DataBridge, which I think is super fun, but you really gotta hang in there with me. I love DataBridge. I'm so sad Dallas and Josh are missing, but y'all need to watch this video. Okay, so how many passages are on the science section of the ACT?
6.
Yes, and then about how much time do you have for each one of those passages?
550.
Very good. All right, now we also know that one of those passages is going to be what kind of passage? Conflicting viewpoint. Very good. And I think maybe I'm going to skip to conflicting viewpoint on Monday so you can have it before y'all take the pre-ACT and the ACT. All right, let's talk about locators in the science section. They are related to locators in the reading section, but they're a little bit different. What do 2 things do locators in science questions tell you?
Where to look and what to look for.
Yep, where to look and what to look for. And give me an example of a where to look. Like table 1, very good, okay? Give me an example of what to look for.
Units.
Yes, units, very good. Or maybe it tells you the solution you're looking for and you see, oh, I'm looking for HCl and that's on the x-axis. So everybody got it? Okay, now let's talk about number, behavior, and trends, okay? We talked about how really you need to be able to identify how numbers are changing and how they're related in those variables. We talked about that yesterday. And then what about math on the science section? Is it hard? Do you need your calculator? It's easy. And a lot of times they want you to do what?
Estimate.
Yep. So they want you to kind of do it in your head. All right. What does it mean if you have a question and they give you a graph and in order to figure out the answer to the question, it is going to be off that graph or off that table? What are you going to have to do? Right. And what's that word for extending it? Extrapolate. Very good. And after you extrapolate, then you have to, yeah, because you're not drawing it to the same precision that they are. So you kind of have to estimate. You actually know when you're having to estimate and extrapolate, usually because the answer choices will be like between this number and this number, right? And so they're not asking you for an exact number. And so that should tell you, oh, I probably need to estimate here. All right. One thing I have not said very often to you guys is in science, I do not advise you beginning with reading all of the study and trying to understand the science in the experiments, okay? A lot of times the science is going to be above your head. It's above my head. All I want you to do is figure out how to find the answer, right? Now, sometimes you might need to go read the paragraphs that are there. It just depends on, but I always advise you to first start with the questions and use your locators and try to find your answers that way. But don't get bogged down in the science. You don't really need to understand the science that's going on in these experiments, okay? All right, so let's look at these extrapolation questions that we started on yesterday, and let's walk through them. Okay, so did we do 16 in class? What is that the one we ended with yesterday?
Yes.
Okay, so I am ahead. Okay, so let's look at 17. All right, so according to figure 1, right? So what's your locator? All right, so at negative 10 degrees Celsius, the mass of NaCl that is soluble in 100 milliliters of water is. Okay, so let's look. So where are we going to have to extend this graph? to negative 10 degrees, right? To your left, right? And then which solution are we looking at? The locator also tells us which one we're looking at. And how is it denoted on this? The solid straight line. Okay, so try to figure out about the distance between 0 and negative 10 and kind of extrapolate. So extend your graph. Use your pencil to do that. And then once you've got that, try to kind of extend that NaCl line and see about where they meet. Where do you think about they meet? Yeah.
Around 75.
So, right. So if they, do you agree, Sadie? If you extend NaCl line up to the negative 10, do you think it would be, which do you think is your best answer choice? Mm-hmm. Yep, greater than 60. So you were right, Kylie. Okay, see how that works? All right, let's try 18. According to figure 1, at 100 degrees Celsius, the mass of HCl that is soluble in 100 milliliters of H2O is what? Okay, so now this time you need to extrapolate even further to your right on your x-axis, right? But this time we're looking at HCl. How is HCl denoted? Yep. So extend those two and see where you think they hit. And then figure out which one is your best answer. What do you think? Okay. What do you think, say it again?
Yeah, I would say H because I feel when I extended it out, I feel like it's like almost right at 60. So I didn't think it could be greater.
H is the right answer. Okay. All right, now we're going to get a chance to extrapolate on a table, which is a little bit different. So look at, it says, suppose trial 3 had been repeated with a block mass of 10 kilograms. According to table 1, the block speed measured would most likely have been what? Okay, so now let's look at table 1, look at trial 3, okay? And we see that when it was 8, the block speed was 2.4, right? So now let's say, and if you look, when the heavier it is, right, the faster it's going. Do you agree? So, because when it's 4, it's going 1.7. When it's 6, it's going 2.2. When it's 8, it's going 2.4, right? So if it's heavier, is it going to go faster than it did when it was 8? Yes. So which one of those would be your answer? Yep. Greater than 2.4. Good. Okay. Now let's look at 20. Suppose trial 4 had been repeated with an incline elevation of 35 degrees. According to table 1, the block speed measured would most likely have been what? All right. So let's look at trial 4. It was incline of 40. So let's say we're going to, and its speed was 3.7. And let's say we're going to decrease that incline to 35. Correct. Good. Yay. Y'all feel like you got this? It's not.
I feel better on the extrapolations.
You do?
Yeah.
Good. So here's the thing, you absolutely will have like 1 or 2 of these on the ACTs. And if you're not a trained test taker, you start thinking, oh my gosh, they're giving me a graph and I have to find an answer off the graph. Well, yeah, that's the point. You've got to extrapolate and estimate. Okay?
Even next week?
Yes. Yeah. You will see it on the pre-ACT. Do you think this is harder?
No, the one that we just took the sign.
Was harder, yeah. Okay, DataBridge. You're gonna love DataBridge, but I want you to get out your science, your 3-ring binder, and turn in there to your science tab and your running strategies, right? So I'm going to stop sharing this for just a minute. And I am going to, oh no, I can go whiteboard. That would be fun for them. Okay, so we're going to talk about DataBridge. DataBridge is huge on the ACT section. So like next to locators, I think this is maybe one of the most useful skills that you can have. So let's see. I'm going to. You thought you were going to die? Oh, darling. I promise. I'm not going to kill you. I'm not going to let you die. It's because that thing is so heavy.
Is it a way to blame?
It's
like I picked it up and I like could not pick it up.
It's 15 pounds. It is 15 pounds. Okay.
Workout.
I know.
I was wondering why the chair was leaning back more than usual. I was like,
That's why. Okay, so stay with me. I got to go back. All right. Oop, I didn't pause the recording. All right, sorry guys. We had a little mishap. Sorry I recorded that. I thought I'd stop. Okay, everybody look at the example on page 17. Do you see the 2 graphs there or the 2 charts?
yes.
Okay, look at both of them and see what is the variable that both of them have in common.
V.
Yes, okay, and that's voltage. That's the scientific notation for voltage, okay? So if you look on the x-axis of both of those charts, so that is your data bridge. Does that make sense? Okay, so now what we need to do is walk through the next steps of what we do. When you are looking at a data bridge and you know you need to use the data bridge, there are 2 pieces of information that you need to know. And so you are going to have to actually use both graphs in order to find your answer. So you have to figure out, how do I start? Okay, so which graph do I start with? Well, here is your answer. You are going to start with whatever graph has the variables that are in the question. You are going to end with the graph. I'm going to say this again. You're going to end with the graph that has the variables that are in the answer choice. Okay, so look at question number 21. Okay, so in the question it says, based on figures 1 and 2, that's your warning. Hey, you need to use DataBridge. It says when the resistance of device 2 is 3 ohms, the current I is approximately what? Okay, so what variable is actually in the question that you also see on the graphs?
Figure 1. On the y-axis. It says figures 1 and 2.
Uh-huh.
So but wait, it has the current I.
Okay.
But there's and then there's the I over here.
Right.
But the MA is on the y-axis.
Right. So the MA is on the y-axis, and so in figure 1. So figure 1 is the second graph you're going to deal with. You're going to end on figure 1. So look at the question again. Which one has the variable in the question that they're asking about?
This thing.
The little omega, right? The ohm, right? So you are actually going to start in figure 2, okay? So here's step 3. I need to write step 1. Let me go back to my whiteboard, okay? So step 2, identify the data bridge variable all have in common. Step 3. Okay, I'll tell you why. Okay, so when you look at your answer choices, you see your answer choices are MA. And so you look, which one of these has MA? Oh, it's figure 1. So my answer, because see, it says it's asking you, this is actually what they're asking you for. So your answer is going to be the IMA. So that means that your answer is going to be here. So that means if your answer is here, this is where you're going to end. So you've actually got to start here. And if you look in this question, it says the resistance of device 2 is 3 ohms. Oh, well, this is the one that has that. Okay.
I guess that's why I was getting confused. I thought you meant that my answer was going to be here, and that's why I was confused.
No, your answer is going to be in here. So you've got to start here. All right. So let's write this. step 3, look at the variables in the question and in the answer choices. Okay, start with the graph or figure, whatever, or table that has the variable in the question. Find the DataBridge, then move to the graph or figure, whatever, with the answer choice variables. Okay, so the best way for you to understand this is for me to walk you through an example. So let's move back to this and let's look at this example, okay? So look on, all right, so just listen to what I'm trying to say and see if you can figure it out. So 21 says, based on figures 1 and 2, that lets you know you need to use the DataBridge. It says when the resistance of device 2 is 3, then the current I is what? So here's what we do. We start with the figure 2 because it's got the resistance in it. So everybody go to figure 2, and it is asking you about device 2. So device 2 is the line with the circles, all right? So everybody put your finger on the line with the circles, and now find where the resistance is 3 for device 2, okay? So the resistance is on the y-axis, so find between 2 and 3 and kind of take your finger and draw over till it hits device 2. Everybody got it? So now we know that voltage, the EV at the bottom is your DataBridge. So now find a value where the resistance is 3 for device 2. What's the voltage going to be?
Wait. I have the circles don't hit they don't hit any of the other ones.
What do you mean they don't hit any of the other ones?
What do you mean? And the resistance of device 2 is 3.
So now the voltage is about what?
Resistance.
Okay, so this is device 2, right? Okay, so and then this is resistance. So the resistance is like 3 right here. So go over here and just draw it until you hit device 2. And what's that value for voltage?
It's about 3 and 4.
Somewhere between 3 and 4, right? Okay, so
3.
all right.
I said it's closer to 3, so
You said between 2 and 3?
no, I said closer to 3. So when I put
Okay, wait, we're working on this one.
oh,
Okay, so now, so that, since voltages are DataBridge, and we found that the value, when the resistance is 3 for device 2, the voltage is somewhere between 3 and 4. Everybody agree with that? So now what you're gonna do is you're gonna go to the graph that has your answers on it, and you're gonna actually go over to voltage, because that's your DataBridge, and go between 3 and 4, and now take your finger and draw until you hit device 2. What is about the current on the y-axis for device 2 when the
6.
voltage is somewhere between 3 and 4? Yes, 6. So what's your answer?
6.
Yeah, or D, right? Okay, does everybody see how we did that?
Mhm.
You see how we did that? Okay, so now let's practice. I'm gonna let you practice on 22. So use those exact same steps for 22. So it says based on figures 1 and 2, so that tells you, hey, I've got to use the DataBridge. All right, so, and it says when the current of device 1 is 1 MA. So now, which one am I going to start with on this question? Which graph?
The second one. The first one.
The first one, right, because figure 1 has the MA on the y-axis, right? the resistance is approximately. So now you're looking for resistant in your answer choices. So that means you're going to, your answer is going to actually be on figure 2. So voltage is still your data bridge. So now, but this time, remember, you're looking at device 1. So follow those steps and see if you can figure it out. And while you do that, I'm going to write this for these guys.
Because I got on figure 1.
What'd you get?
Oh.
You got G? What did you get? You got H?
Yeah.
Okay, G is correct. Okay, so let's look at what you did.
I guess because I went right here.
Okay, so did you start up here?
I
Okay,
had this little one.
right there. All right, so you would say, so device 1 is 1. So this is device 1. So when it's 1, but so when it's 1, yeah, so it's about 0.5, right?
So should I have gone to 0.5?
So yeah,
1?
so 0.5 and then go up.
I think that's what I did because it was like, okay, that's closer to 1, and then I went to 1 and did it. So I guess that should have been here somewhere.
Mm-hmm.
Then yeah, that was me right.
Yep, that makes sense? Okay, now.
Wait, I'm sorry, I'm so confused about 3.
Okay, so look, so when it's 1, right? So device 1 is, it's really, I would say, it is kind of confusing. So if you got 0.5 for device 1, it really, I mean, this I think is a really persnickety one.
I feel like it could be either one.
I think it probably could be either one too, but I think if you look at it for when it's 1, it really may be a little bit closer to, oh, that's why.
What?
When it's 1, when the current is 1, the voltage really is 1.
Yeah, see, I went to 1.
So, but look, I know it's real, and probably on the ACT it wouldn't make it this easy, but it's really not 4. So it's really not all the way up to 4. It really hits about there, device 1. So it's really not 4, it's under 4. So I think that's why.
So it's
they gave
under
3.
4, I should go with 3.
I guess. I don't think the ACT would make it that obvious though. I mean, make it that close. Yeah. Okay. All right. So now we're going to practice. Turn to page 18. We're going to practice using the DataBridge on 23 through 26, but this time it's going to be a table.
Wait, but this is an ACT book.
Mm-hmm.
So what? They could make it that.
Well, this is not technically an ACT book. It's technically, it's to help you prepare for it, but ACT didn't actually write it. So, all right. Turn to 18, page 18, and do those, and let's see how you do.